Good everyone. I'm Gideon, currently in mechatronics. So this afternoon we treated some past questions, some likely questions that come out every year, most that are likely to come out in your post-UTME, specifically chemistry. So we'll be diving into the first question without any delay. So you have the questions on your screen here. So the first question is giving a chemical reaction. I'll write out the chemical reaction. It says CH3COOH reacts with zinc, and it gives what? So this is a displacement reaction. So the zinc is a more electropositive metal. So it reacts with this an organic acid. So it displaces this hydrogen ion, and it gives us this. Gives us CH3CO zinc plus, and it gives us gas, but this is not a balanced equation. So because this is plus one and we have, it must give us gas, so we just two here, and this is plus two, so this in the bracket, this is two, no, two here subscript. So the answer from the question there, the answer is C. So don't mind the question the way it's typed. It was supposed, the two is supposed to be written as subscript, not as a normal number. Now going to the next question. Say the products obtained when the following chemical reaction is completed and balanced are. So number two, this is the chemical reaction. Chemical reaction. The equation representing the chemical reaction HNO3 plus CaOH 2. So they were asked to get the product, and from we can only get the product from the balance equation. So this is a neutralization reaction. So we know basically from a neutralization reaction, two products are produced. We have salt and water. So if we write out water first, we know to form water, one hydroxyl ion acts with one hydrogen ion to form one molecule of water. So we are already having two hydroxyl ion here. So to balance it, we put two here so that the hydrogen ion can be two. So we have two molecules of water. So from here, to balance this, the salt should be CaNO3 2. This is balanced because Ca is 2 plus 2, and this is NO3 is plus 1, and so it takes 2. So this is the balance equation. So the correct answer, the correct answer is B, just as you have it on the board here. So we go to the third question. The third question says the following substances are non-electrolytes except, so we have A, we have chloroform, B, we have sugar cane, and C, we have acetic acid, D, we have NaCl, that is sodium chloride, then E, we have C and D. All these solutions, all these solutions and substances that are mentioned, they are all electrolytes. They are all electrolytes. So they said except. So the only odd answer there is we have E, C, and D. Although all of them are all electrolytes, the only odd option is E. So moving to the next, we have question number 4. Question number 4 says the hydrolysis of ammonium chloride NH4Cl. The hydrolysis of ammonium chloride salt will give what? Okay, we have to know what type of salt it is. So ammonium chloride plus water, when we dissolve it into water, So this is a salt from a neutralization reaction, a reaction between an acid and a base, and the base is NH3OH. This is a weak base. This is a weak base. Then this chloride is from HCl, which is a strong acid. So this forms a sort of is weak base and a strong acid. So when it is dissolved in water, we have four ions, four types of ions. We have NH4 plus, and we have OH minus, and we have H plus, the water molecules that split because it's dissolving in water, and Cl minus. Now because this is a weak base, it will combine with this OH, because weak base or weak acid, they don't dissociate easily, they hardly dissociate, but strong acid or strong base, they dissociate easily. So they still remain as ion, but this will combine again to form NH, NH4, NH4OH. Sorry, this is NH4, NH4OH. So, but this will remain as ions in the solution. So the solution becomes acidic. So we have it in the option there. The salt A is the answer. The salt becomes acidic. The solution becomes acidic because as this is converted to base over time, we only have hydrogen ions which make the solution acidic. Now, number 5. Go to number 5. The pollutants that are likely to be present in an industrial environment are A. So I'll be writing out the options. We have H2, hydrogen sulfide, which H2S, SO3, sorry, SO2, and oxides of nitrogen, nitrogen oxides, nitrogen oxides. Then B, we have NH3, and we have HCl, hydrogen chloride, and we have CO. Then C is, we have CO2, NH3, CO2, NH3, and H2S, which is hydrogen sulfide, and we have D. D is dust, NO, and fluorine. Now I want you to pay attention. So we have to pay attention to the options so that we can choose. So they said industrial pollutants. Industrial pollutants are waste generated from industrial processes. So if you look at these ones, these are the likely ones you might have, but let's not stop there. Going to this, NH3 is one of the important compounds, is a heavy chemical, is used in industrial processes, so it cannot be a pollutant. It is used because it cannot be given out as waste, and as well as hydrogen chloride. The same thing goes for this. As far as ammonia is still there, ammonia cannot be given as a waste. So this also, chlorine is used in the production of hydrochloric acid, hydrogen chloride. So this cannot, it's not this, it's not this, it's not this. So the answer is this: hydrogen sulfide, SO2, and oxides of nitrogen. So now we go to the next question. The next question is number 6. It says, what is the basicity of tetraoxosulfate 6 acid? Let me write out the formula: H2SO4, tetraoxosulfate 6 acid. Now the basicity of an acid is the amount of number of hydrogen ions it can give out when it reacts with a base, or when it being dissolved in water. So if we dissolve this in water, how many hydrogen ions do we get from this? We have 2H plus, be having two. So the basicity of tetrahydrogen sulfate 6 acid is 2, which the answer is A. Now to the next question. The next question says, which of the following gases is the most dangerous pollutant? Which of the following gases is the most dangerous pollutant? We have A hydrogen sulfide, then we have B carbon 4 oxide, then C we have sulfur 4 oxide, then D we have carbon monoxide. Carbon monoxide. So looking at this, hydrogen sulfide, yes, is dangerous, but they say all these gases are dangerous. But which is the question says which is the most dangerous pollutant? They are all pollutants. This gives um stink, a stench, a foul stench, but it's not as and this also is dangerous. This is a product from the combustion of um organic gases, organic compounds. But this is the most dangerous of them. This is the most dangerous of them. Carbon monoxide, because it chokes, is very dangerous to. It combines with our hemoglobin, and it leads to a reduction reaction. So that is why this is the most um, dangerous pollutant, because it leads to suffocation. Now go to the next question, number 8. We have, which of the following ions is a pollutant in drinking water, even in trace amounts? So we have A, we have calcium, B, we have mercury, then C, we have magnesium, then D, we have iron. So which of the ions, plus 2, this is plus 2, this is also plus 2, and this is plus 2. So which of these is the most dangerous? The answer is B, mercury, because these are micronutrients that our body even need. So if they happen to find their way into water, our body can make use of them. But this is a poisonous. So this is the right answer. So moving to the next question, number 9. So which of the following is an example of a double salt? Which of the following is an example of a double salt? We have NH4 ammonium chloride, we have B alum potash, we have alum, which is the short form for alum potash. Then C, we have sodium carbonate. Then D, we have aluminium chloride. Then E, we have sodium chloride. So which of these is a double salt? Now a double salt is a salt that when it dissolves in water, it produce at least two positive ions and negative one negative ion. So aluminium potash is in this form. Then there's a, let's say, NO3, something here. So once you dissolve this in water, we have potassium ion and aluminium ion. So potash is a double salt. Aluminium potash. Okay, in the option is alum, but the full is aluminium potash. So alum, the answer there is B. Question number 10 said elements PQRS have 6, 11, 15, and 17 electrons respectively. Therefore, I'm going to write out the elements. Number 10, we have P, Q, R, S. So P has 6 electrons, Q has Q has sorry, Q has 11 electrons, R has 15 electrons, S has 17 electrons. So the question is now, the options are P will form an electrovalent bond with R. Okay, let's know which and which will can form electrovalent and covalent bond. So this is, we write out the KLMNO format for this. So P element P has 6 electrons, so have 2, 4. Q has 11 electrons, you have 2, 8, 1. Then R has 15 electrons, you have 2, 8, you are left, then 5. Then this S has 17 electrons, you have 2, 8, 7. So looking at this now, we have these can only react in can only form covalent bonds. This this can form electrovalent bond because it has has just one electron in the outermost shell, so it's easy to donate. Then this is more electronegative because it needs one more to complete this shell. So we know this is electrovalent. This will get involved in will form an electrovalent bond. Then this and this will form covalent. Now we look into the options. We say therefore A, Q will form an electrovalent bond with R. No, R cannot form an electrovalent bond. So B says Q will form a covalent bond with S. Looking at it, Q cannot form an electrovalent bond with S because there will be transfer of electrons, and covalent bond is sharing of electrons, so it's not B. Then C, R will form an electrovalent bond with S. Again, no, because looking at it, R has 5 electrons in the atom shell, so it has to share. And this one, this element S does not have any to transfer. It can't share because S is electronegative. It has to receive. Then D, you have Q will form. D says Q will form an electrovalent bond with S. Yes, that is um, the the correct pair. We know that electrovalent bond is formed when there is transfer and acceptance of electron. So these are the two elements that can form electrovalent bonds. So we move to the next question. Next question, number 11. Number 11, it says in the oil drop experiment, Millikan determined the charge to mass ratio of the electron, B, mass of the electron, C, charge of the electron, D, mass of the proton. Now, in that experiment, he discovered two things. First, he discovered the charge of the electron, and he also discovered the charge to mass ratio of the electron. But his major goal for that experiment was to determine the charge of an electron, but he later discovered, so the answer there is C, which was the major reason why he conducted that experiment, the charge of the electron. Now going to question 12. Question 12 says one of these atomic shell is the most stable. One of these atomic shell is the most stable. We have A, M, B, N, C, K, and D, L, and E, O, 0. The most stable is the one close to the nucleus. So if we are to draw the nucleus, a model of an atom, this is K shell, this is L shell. So the one closest to the nucleus is the most stable. and K is the one closest to the nucleus. So K is the most stable atomic share, and the answer for that is C. Now moving to question 13. Question 13 says sieving is a technique used to separate mixtures containing 20% oxygen by volume. Which which of the following was which of the following reactants was in excess? So the question there is A, because because we need, when carbon two oxide, which is carbon monoxide, when you supply oxygen to carbon monoxide, it it reacts and it forms CO2. So the question says which of the reactants was in excess. So I think is carbon monoxide, which is A. Now number 14. The question number 14, it says the number of electrons in the outermost shell of the atom represents its A period, B number of shells, C group, D atomic number, and E electronegativity. The answer is C, the group. So the number of electrons an atom has at its outermost shell is determines the group, what group it falls under. Now to the next question, number 15, we have, it says the number of protons or electrons of an atom represents its A electronegativity, B period, C number of shells, D group, E atomic number. It says the number of protons and electrons in a stable atom, there are equal number of protons and electrons. So the number of protons and electrons in an atom tells us, it gives us the atomic number of that element. Now to the next question, number 16, says the of CO2 shapes of CO2 and H2O H2O and CH4. Okay, now the shapes the shapes of these compounds, respectively. Okay, the shape of this, C, we have bonds with oxygen. So this is linear. It forms CO2 forms a linear shape. Then H2O, we have H, we have O. Because of the repulsion of these electrons, they repulse themselves to form an angle of 105 degrees. So this is bent. Then CH4, which is methane. Methane is tetra. Yes, it is. Methane is tetrahedral. So this is it. So the order in which they appear respectively: A, you have bent, linear, tetrahedral. Or the correct answer is linear, bent, tetrahedral, and the answer to that is in D. Answer D. So to the next question, we have the next question, number 17, says the compound this compound exhibits ionic bonding. So they listed some compounds in the options. So which of them exhibits ionic bonding? A, we have H2O, B, H2, C, KCl, D, NH3, E, HF, hydrogen fluoride. So the correct answer is KCl. KCl forms an ionic bonding because it's a salt. There's transfer of electron from calcium to the chlorine, and they come together to form a compound. Now to the next question, we have the next question number 18 says this type of bonding involves overlapping of orbitals during which electrons are shared. The overlapping of orbitals and there is sharing of electrons. So the question option A says hydrogen bonding, B says covalent bonding, C says ionic bonding, D says metallic bonding, van der Waals bonding. The correct answer there is B, covalent bonding. Covalent bonding and dative covalent bonding are the only types of bonding that involve sharing of electrons and overlapping. So the correct answer there is B, covalent bonding. Now moving to question number 19, it says which of the following reactions is correct? Which of the following reaction is correct? A, we have benzoic acid C6H5 COOH plus C, this is option A, plus CaO, and in the option it gives us the product it gives is C6H5CaHCO3. This is wrong. This is wrong because this type of reaction, this because it's not balanced, because for this is 2 plus, and bringing it here, this there's only one shared electron here, but this is 2 plus, so it can't go. So the correct option is B, C6H5COOH. Benzoic acid, when reacted with calcium oxide, gives gives benzene and calcium carbonate. The correct answer is B. Now to number 20, you said the name of the gas driven off at the negative electrode during electrolysis of brine is. Now brine is the industrial name for concentrated NaCl. So during the electrolysis of brine, sorry, during the electrolysis of brine will be dissolved in water. So we have negative and positive electrode. Negative and positive electrode. So the positive ions, which will be Na and H plus, they will move to the negative electrode, while the negative ions, which is Cl and OH minus, they will move to the positive electrode. So the gas that is given off at the negative electrode is hydrogen. This is the reaction for it. It says at the electrode we have 2H plus 2E give you H2, which is in gaseous form, because in the electrochemical series sodium is more electropositive than hydrogen, so the hydrogen will be preferred to be given off than sodium. Now we go to the next question number 21. The question is not actually clear, so I think we'll skip down to question number 22. Question number 22. Question number 22 says the oxidation number of sulfur in this chemical compound HSO3 HSO3 2. What is the oxidation number of sulfur? Okay, let the oxidation number of sulfur be equals to X. So we already know the oxidation number of this is 2 plus, and the oxidation number of this is plus 1. The oxidation number of this is minus 2. So we'll go, we'll solve for the oxidation number of X. We'll replace S with X. So the oxidation number, we add all the oxidation numbers together. So we know the addition of 2 of calcium, 2 plus 2 plus into bracket plus 1 plus X, which is S, then plus minus 2 times 3 because of this 3, then all multiplied by 2 because of this 2. It should give 0, because in the chemical compound is not charged, is neutral. So when we solve this, we have 2 plus, opening the bracket, we have 2 plus 2x. This will give minus 6. Minus 6 times 2, that is minus 12. Minus 12 equals to 0. So simplifying this, we have, this will give me 4 plus 4 minus 12, that will give me 2x minus 8, that is equals to 0. So 2x is equals to minus 8 plus 8, sorry, divided both side by 2. So X, which is the oxidation number of sulfur, is equals to 4 plus 4. So for the right option there is C, plus 4. Now moving on to the next question, question number 24. Question number 24 says the mixture of iron and sulfur can be separated by dissolving the mixture in. This is a separation technique question. So A, steam; B, dilute hydrochloric acid; then dilute dilute hydrogen, sodium hydroxide; D, benzene. So the answer is B, dilute hydrochloric acid, because you have a mixture of iron and sulfur. So this is a metal. It won't react with sulfur, but it will react with this, because this is more electropositive than hydrogen. So let's say 2, yes, 2, and we have iron chloride plus hydrogen gas plus sulfur. So this is what we can use to separate this. So we can separate sulfur. We have separated sulfur. So the correct answer there is B. So number 25 says a mixture of sand, ammonium chloride, and sodium chloride is best separated by A, sublimation followed by addition of water and filtration; B, sublimation followed by addition of water and evaporation; C, addition of water followed by filtration and sublimation; D, addition of water followed by crystallization and sublimation. Okay, now let's see the mixture we are having. The mixture we're having is sand, having sand, ammonium chloride, having sand, ammonium chloride, and sodium chloride. So to know the best separation technique for this, we must know their characteristics. This is not soluble in water. This is soluble in water. This is also soluble in water, but it can sublimate. So we need to separate them. See, we cannot dissolve it in water first, because this will still be stick together. So we sublimate first. So this is giving off. It's sublimation is giving off. Then we dissolve. Then after we dissolve, we filter, then we get sand as our residue. So looking at the options, The correct the correct series of separation technique is A, sublimation followed by addition of water to dissolve, then filtration to get out a sand as our recipe. So moving to the next question, we have question number 26 says a pure solid usually melts A over a wide range of temperature, B over a narrow range of temperature, C at low temperature than impure one, then D at same temperature as impure one. Okay, a pure solid will always have a definite just one melting point, but if it's impure that means it has other elements in it. There will be the melting point will vary. So so the answer is B, over a narrow range of temperature. A narrow is very specific range of temperature. Then going to number 27 says a small quantity of ammonium chloride was heated gently in a test tube. The solid gradually disappeared to produce a mixture of two gases. Later, a white cloudy deposit was observed on the cooler part of the test tube. The ammonium chloride is said to have undergone sublimation. This is sublimation. We already know from here ammonium chloride when it's heated it can sublimate, it can change directly from solid state into gaseous state. So this that is sublimation. The answer is there is B. Now, number 28. 28 says the process of changing one element into another is called A. Radioisotope, B. Radioactivity, C. Dating, D. Transmutation, E. Nuclear reaction. The correct answer there is D. Transmutation. So going to question number 29. Question number 29 says, which of the following changes is physical? A. Adding of iron filings to aerated water. B. Adding sodium metal to water. C. Cooling of a solution of iron to sulfate to obtain dehydrated salt. D. Cooling water to obtain ice. Now, a physical change, yes, a physical change is one that does not involve chemical reaction. There's no chemical change. There's no changing of one. It still remains the same. So the answer is D. Cooling of water to ice. Because when you cool water to ice, because water when you cool water to ice, it's still the same chemical compound. So there's no chemical reaction here. So it's just that's the only physical change in that in the options. So we move on to the next question number 30. It says a side effect of salt water is that A. It gives offensive taste. B. Excess calcium is precipitated. Then C. It encourages the growth of bacteria. D. It attacks lead containing pipes. The answer is D, because salt water has some minerals in it that when they are being transported through pipelines, they can corrode they can produce a chemical reaction that can corrode the pipeline. So the correct answer to that question is option D. Moving to the next question, we have number 31. Ammonia is very soluble in water because it's a dash. A is a dash molecule. A non-polar, B polar, C. Reactive. D. Basic. C. Acidic. The correct answer is B. Polar. Any substance that can be dissolved in water is a polar substance, because they said polar polar solvent would dissolve polar substance. So since water is a polar solvent, it can ammonia is able to dissolve in water because it's a polar molecule. Then moving to the next question, number 32, it said a charged car battery has dash energy that can be converted into another energy called dash energy. Now, a chemical, it has chemical energy which can be converted to electrical energy, B mechanical to chemical, C heat to mechanical, and D light to electrical, and E light to heat. The correct answer there is A chemical to electrical, because battery has acids in it and electrodes that helps it convert chemical energy to electrical energy. So going to the next question, you have number 33. You have it says copper oxide is heated with charcoal to produce carbon monoxide. Copper oxide is heated with charcoal to produce carbon monoxide and copper. The reaction is an example of A. Both oxidation and reduction. B. Neither oxidation and reduction. C. Oxidation only. D. Reduction only. Then E. Neutralization. Okay, I would like to show the solution to this on the board. So the answer is, though the answer is A, copper oxide. Let me tell us what oxide it is. Copper oxide, I will assume it's copper monoxide. So since it was heated with charcoal, charcoal is carbon. So Cu, we have it produce copper and carbon monoxide. So this is an oxidation reaction. Oxidation and reduction occurs in this type of reaction. The transfer of oxygen to the carbon, and this is carbon is oxidized while copper is reduced. So that is the oxidation and reduction reaction. So moving on to the next, we have number 34. 34 says one of these elements is the best reducing agent. We have A is lead, B is rubidium, C is aluminium, and D is indium. E is nitrogen. The answer is B, rubidium. Rubidium. Rubidium is more among all the ones that is mentioned. It's the most electropositive. It's under the group one element. So it's oxidation. Reduction is the acceptance of electrons. So it's the one that initiates the reduction reaction. So that's why it's the best reducing agent among the options. So your answer there is B, rubidium. Now number 35, it says when heat is absorbed during a chemical reaction, the reaction is said to be when heat is absorbed during a chemical reaction. When there is absorption of heat, that means the enthalpy change in heat is positive. Positive. It absorbs energy from the environment. That means it's endothermic. It's an endothermic reaction. So the answer to that is D, endothermic reaction. Now, number 36. Number 36 says, given the reaction at equilibrium. So I'm going to write out the chemical equation to this question. We are given the chemical equation. Number 36 says the given the reaction at equilibrium, two molecules of carbon monoxide in gaseous state with oxygen also in gaseous state, then there's a reversible reaction that's showing that it's at equilibrium. So we have two carbon dioxide, two molecules of carbon dioxide. So from the option says, the question says, when the reaction is subjected to stress, a change will occur in the concentration of A. Okay, now there is at equilibrium, dynamic equilibrium. It's proceeding in both forward and backward reaction at the same rate. So it's at equilibrium. So there's a stress applied, and stress is equals to force over area, force per unit area, and this is also pressure. So if there's a pressure applied, if pressure is applied to this system, there will be a change in the reaction of A, the reactants only, B, products only, C, both reactants and products. Then D, neither reactants nor products. The answer is C. See both reactants and products, because when there's a pressure is applied, the reaction goes in this direction. No, sorry, reaction goes in this direction so as to reduce the pressure. Because you have three volumes of gases here, and we have two volumes. So it proceeds in the direction that has lesser volume so that it can accommodate the pressure. So this there's an increase in this concentration and there's a decrease, so there's a change in both the reactants and products. So the answer to that is C, both reactants and products. Now moving to question number 37. So given the reactions at equilibrium, this is also an equilibrium question. The reactions at equilibrium, nitrogen gas reacts with oxygen gas and it's at equilibrium produce nitrogen oxide. So given this reaction at equilibrium, as the concentration of nitrogen gas increases, when the concentration of this increases, the concentration of O2 will dash A decrease, B increase, C remain constant, D vanishes, E falls away. The answer is A, decrease. Because the more, if this increases and this remains constant, if nitrogen increases and oxygen remains constant, we have more nitrogen to react with the oxygen. As far as there's no more oxygen added, so the amount of oxygen will be depleted, which is it will be reduced, and it will shift to the right hand side. So that's it. So the answer to that question is A. It will decrease. Now moving on to the next question. Question number 38 says, if a reaction is exothermic, the reaction is exothermic. Number 38. If a reaction is exothermic, sorry, it's that means the enthalpy is negative. The enthalpy Hp minus Hr is negative. So says if a reaction is exothermic and there's great disorder. Now disorder is the measure of entropy. There is great disorder, that means high entropy, and it's negative, and the enthalpy is negative. It is an exothermic reaction. It means that A, the reaction is in a state of equilibrium, That is not correct. B, there will be a large increase in free energy. C, there will be a large decrease in free energy. Then D, reaction is static. Is static. Sorry. So the right answer to that question is B. There will be a large increase in free energy. So this is the formula for Gibbs free energy. Gibbs free energy is given by this H minus the temperature multiplied by the change in entropy. So this is the formula. Since we already have a great entropy and this is already negative, so Gibbs automatically, so therefore Gibbs free energy is will definitely be negative, since this is greater, is large, and this is also negative, so Gibbs free energy will be negative. So it will have high, it will have, there will be an increase, large increase in free energy. So now moving on to the next question, question number 39. It says in the chemical reaction of A plus B, let me write out the chemical reaction. Chemical reaction of A plus B, A plus B, which is equals to C plus D. Say more of D is formed dash A if the concentration of A is reduced, B if the concentration of B is reduced, C if the concentration of C is reduced, D if the concentration of C is increased, and E if it is continuously removed, from the reaction. So the answer is E, because let's say this is going in this direction, is in equilibrium. So as far as this is constantly reduced, more will be produced from the, this is the product, this is the reactant, more will be produced, more of D will be produced from the reactant. So there will be a shift in forward reaction, so as to make up for the removal of this, so more of D will be produced. So going to the next question, number 14. You say in what way is equilibrium constant for the forward reaction related to that of the reverse reaction? In what way is equilibrium constant for the forward reaction related to that of the reverse reaction? It says A, the addition of the two is expected to be 1, the product of the two is expected to be 1, C, the two equilibrium constants are identical, D, the product of the two is always greater than 1. So the answer is C. Say the answer is C, which says the two equilibrium constants are identical. The two equilibrium constants are identical, given by this formula. So we have, okay, let me take this, yeah, again as my, let me take this as my equation. So we have C over C plus D is over D over A is over A plus B is over B. Since they are constant, since they are the two, since the two equilibrium are constant, that means this, so the equilibrium constants will also remain constant. Moving on to the next question. Question number 41 says here, say in which reaction will the point of equilibrium shift to the left when the pressure on the system is increased. Okay, so I'll write all these reactions out so that I can show you. So the option A, have carbon is solid plus oxygen gas giving carbon dioxide gas. So we also have B, calcium carbonate, which is solid, gives calcium oxide plus carbon oxide gas. This is solid. Then C, we have magnesium, 2 moles of magnesium with oxygen gas giving magnesium 2 oxide, which is solid. Then D, we have 2H2 gas plus oxygen gas to give 2 moles of water. So from here, says pressure is, it says in which of these reactions will the point of equilibrium shift to the left when the pressure on the system is increased. Okay, increase of pressure. Okay, increase of pressure when there's an increase of pressure in a system where there is chemical equilibrium. So the chemical reaction will proceed in such a way that it will reduce its volume so as to compensate for the increase in pressure. So wherever we have decrease in volume towards the left hand side, that is the answer. So we have, this is one volume, one volume, one volume. So for this is an increase on the onto when coming to the left side. This is one and this is two volumes. One. Then this we have one volume. This is one volume, one volume. Towards this side there is a decrease. So let's also go here. This is two volumes, this is one volume, this is two volumes. Towards this side there is an increase because the total volume here is 3, this is 2. So it's increasing from 2 to 3 towards the left. So here is decreasing. Then this is two volumes, one volume, then two volumes. So this is also increasing. So all of them are increasing towards the left except for B. So B is reducing towards the right. So B is correct answer. So there we have it. So going to the next question, number 42. Say one of these reactions represents the laboratory preparation of hydrogen. The right answer there is E, where we have reaction of metals. Wherever we have reaction of metals, here we have zinc metal reacting with an acid. Here we have hydrochloric acid to give, there will be effervescence of evolution of hydrogen gas H2 and formation of a salt. So the answer is E. So this this is how hydrogen is produced in the lab. So going to the next question, number 44, says the group that oxygen belongs to is collectively called, the collective name for the group which oxygen belongs to. Oxygen belongs to group number 6 if you check in the periodic table, and the collective names for that group is They are called calcogens. Calcogens. So if you check in the description of this video, there is an explanation of what calcogens are. So calcogens are group 6 elements. So that's the collective name for oxygen, the group in which oxygen belongs to. Now going to the next question, question number 45. The ideal gas equation is that you have A equals to P equals A is P equals to nRT, B is PR is equals to NBT, then C says PV is equals to GRT, then D says V is equals to KT, then E says PV is equals to KV. So number 45. The correct answer is A. There's a typographic error here. It's supposed to be PV equals to nRT. From the ideal gas equation, PV N is equals to PV over RT. This is the ideal gas equation. So this is the correct one, which is A. But that is a typo there. There's a typographic error there. So moving on to number 46. Question number 46 says, okay, have to. Question number 46 says 0.16 gram of methane was burnt. 0.16 gram of methane was burnt. Methane 0.16 gram, 0.16 gram of methane when burnt increases the temperature of 1 gram of water. Increases the temperature of 1 gram of water by 4 degrees Celsius. So change in temperature is equal to 400 degrees Celsius. So I say, what is the heat of combustion of methane? If the heat capacity of water H2O, CH2O, heat capacity of water is 4.2 joules per gram per Celsius. So this is the heat capacity of water. So I'll calculate the the combustion heat of methane, because methane was used to heat up a water by up to 400 degrees Celsius, by up to a temperature increase by 400 degrees Celsius. So we must know the amount of energy given to water. So energy given to water, heat energy in form of heat, energy given to water is equals to the mass of the water times the heat capacity of water times the change in temperature. So the change in temperature is 400. So the mass of water is 1 gram. Since our heat capacity is in joule per gram, so we can use this gram like this. So times 4.2 times 400. If we are to multiply it together, we have, I'll be writing it in standard form. We have times 10 raised to the power 4, 4 times 4.2, we have 16.8, which is equal to 16.8, 168.8 joules. This is the amount of heat supplied to the water when methane is burnt. So we want to know the energy, the heat. We want to know, calculate the heat of combustion. The heat of combustion of methane is given as this. So the heat of combustion of methane, which is, permit me to use C. No, let me just say HM. The heat for combustion is this will be in joule per moles times this will be times the number of moles, it will be equals to H. Let me call this HW equals to HW. So to know this, we have to divide HM. We are looking for the heat of combustion of methane. We have to divide HW, the heat supplied to the water, divided by the number of moles of methane. So to get the number of moles of methane, N is the number of moles, is equals to reactive mass over the molar mass of methane. The molar mass of methane is equals to molar mass of methane is equals to 16. We have 12 plus 1 times 4 gives us 3. And the reactive mass, smaller m, is equal to 0.16 as given to us earlier. So we have n is equals to 0.16 over 16. So the number of moles here is 0.01 moles. So we're going to use this here. We're going to use this here, Hm, which is the heat of combustion of methane, is equals to this 16.8 times 10 raised to the power 4 over this 0.01. That gives us, to convert this to standard, to use applying indices. So it makes things much easier, times 10 raised to the power 1 times 10 raised to the power minus 2. So that will give me 16.8 divided by 1, you have 16.8 times 10 raised to the power 4 minus 2. So 16.8 times 10 raised to the power times 10 raised to the power 6 joules. So we have to write that, joule per mole, because we already divided it by the number of moles, joule per mole. So converting this to a standard unit, we have 16.8 times 10 raised to the power 3 kilojoules per mole, which is equals to 16,800 16,000 sorry 1,000 1,680 no sorry 6,800 kilojoules per mole, and this is the answer. Heat of combustion of methane, 16,000. And the answer there, according to the answer there, we have the answer is E. Answer is E. So I think it's a typo. It's 16,800 instead of 1,680. 16,800 kilograms per mole. Then we'll move on to the next question. The next question we have, it says, for each oxygen atom in hydrogen peroxide which acts as an oxidant, there is an oxygen atom which acts as a dash, A oxidant, B reductant, C oxidizing agent, D catalyst, E inhibitor. So the answer is reductant. If one acts as the oxidant, the other will act as the reductant. Now moving to the next question, question number 48 says, given the change in phase, given the change of phase, CO2 gas to CO changes to CO2 solid, the entropy of the system A decreases, B increases, C remains the same, D changes. The answer is A, decreases, because when there's a change in phase from a more energetic, from a more energetic phase to a less energetic phase, there's a decrease in entropy, because we know gaseous phase is more has molecules are more energetic than um, molecules in solid state. So moving on to the next question, we have, it says number 49, it says, which of the following is the entropy change positive? Which of the following is the entropy change positive? It says A, reaction between an acid and a base. B, addition of concentrated acid to water. C, dissolution of sodium metal in water. D, the thermal dissociation of ammonium chloride. The answer is the answer is B. The answer is, sorry, C, because dissolution of dissolution of sodium metal, the entropy change is positive. You know, the entropy change in entropy, change in entropy, which is driven by um change in change in the enthalpy over the temperature. So at constant temperature, we know endothermic reaction, sodium, dissolution of sodium in water. Solution of sodium in water is is an an endothermic reaction. Is an endothermic reaction. So that is why, so for an endothermic reaction, this is positive. The enthalpy is positive, so definitely changing entropy will also be positive. So moving on to number 50. It said chlorine consisting of two isotopes of mass numbers 35. Chlorine, you have chlorine 35 and chlorine 37. So the mass number, they are both isotopes. It says has an atomic mass of, so their relative atomic mass is 35.5 grams. So the relative atomic mass, since there are presence of isotopes, it cannot, we have to, there is presence of this isotope and this isotope. So the average of them based on the percentage in which they appear. So that's what we call the relative atomic mass. So the relative atomic mass, which they mentioned there, is the atomic mass 35.5. So the relative abundance of the isotope of mass 37. So I want to look for the relative abundance in percentage. We look for it in percentage. Okay, so we know that RAM is equals to let me take this, let's say the percentage of abundance of, let x be the percentage abundance of chlorine 35. Let me take it as x. So 35 times x over 100 plus 37 times, if this is x over 100, so for this to be 100 minus x over 100 over 100. So that's how we get the RAM. But now we have the RAM given to us, so we just look for x. Just look for x. Okay, sorry, we are looking for the percentage abundance of 37. So let this be for 37. So this will be 100 minus x, and this will be x, because we are looking for the abundance of chlorine 37. So this will give us 35.5, which is equals to, opening this bracket, we have 3500 minus 35x over 100 plus 37x over 100. So if we multiply both sides by 100, we have 35,501 equals to 3,500 minus 35x plus 37x. So looking at this, if we simplify it, bring this here, we have 3,550 minus 3,500 is equals to minus 35x plus 37x, and this will give us 50, and this will give us 2x. So therefore x, which is the percentage abundance of chlorine 37, will give us 25, will give us 50 over 2, which will give us 25 percentage. So this is for chlorine 37. Chlorine 37. So but it's a known fact, since these are two popular isotopes, have it at the back of your mind that chlorine 37, which is more, has lesser percentage, which is 25 percentage, and chlorine 35, which is the lesser isotope, has more percentage. So this is should be this is a common fact. So moving on to the next question, number 51 said abnormally high boiling point of water is primarily due to A. Ionic bonding, B. Covalent bonding, C. Dative bonding, D. Coordinate covalent bonding, E. Hydrogen bonding. The answer is E, because we have two repetitions there. Dative bonding and coordinate covalent bonding, they are the same thing, but it's not because of dative coordinate bonding. Um, Oxonium ion is formed because of dative bonding. So this is not water at all. So, and it's not due to the covalent bonding, and it's not due to ionic bonding. Water does not have ionic bonds, so it's because of hydrogen bonds. So moving on to the next question. We have number 52 says the number of atoms in 1 mole of substance is equal to the number of atoms in 1 mole of a substance is equal to A, the atomic number, B, Avogadro's number, C, number of neutrons, D, number of electrons, E, gas constant. It's not A, because the atomic number is given by the number of electrons and number of protons. Then is B, Avogadro's number, the total number of atoms in 1 mole, which is given by 6.02 times 10 raised to power 23. 10 raised to power 23 atoms or molecules. So that is it. So moving on to the next question, we have question number 53. It says which is a property of a reaction that has which equilibrium? Which is a property of a reaction that has reached equilibrium? A, the amount of product is greater than the amount of reactant. B, the amount of product is equal to the amount of reactant. C, the rate of forward reaction is greater than the rate of the reverse reaction. D, the rate of the forward reaction is equal to the rate of reverse reaction. The answer is D. So for a chemical reaction to have reached equilibrium, that means it proceeds both in forward and backward reactions at the same rate. So D is the answer, at equal rate. So moving on to number 54. Number 54 says which of the following combinations of conditions may increase the rate of chemical reactions? Which of the following combinations of reactions that can increase or decrease the rate of chemical reaction. So here the options that are given says A, decrease in temperature, increase in concentration of the reactant. B, increase in temperature, addition of catalyst, decrease in surface area of the reactant. C, increase in temperature, increase in concentration, addition of the catalyst, and increase in surface area of the reactant. D, decrease in temperature, concentration, and surface area reactant. E, addition of catalyst in the presence of light. So the answer is C. So there are about four factors that determine the rate of the chemical reaction. So we have temperature, concentration, concentration, presence of light, presence of light, presence of a catalyst, presence of a catalyst, and surface surface area and pressure. Okay, one, two, three, 4, 5. There are six of them. Six of them. Six. This determine the rate of chemical reaction. So an increase in temperature increases the if it's for an exothermic reaction, increase in temperature will decrease the rate of chemical. But if it's for an endothermic reaction, increase in temperature increases the rate. While for concentration, increase in concentration will increase the rate of chemical reaction, while decrease in concentration of the reactant will lead in decrease in chemical reaction. Then the presence of light, light is a form of energy. So if there's presence of light, there are some chemical reactions that are photosensitive. So they increase the chemical reaction. And presence of catalyst, if the catalyst is a positive catalyst, it will help facilitate the forward the rate of reaction. Then surface area, the amount of area of this reacting surface, then pressure. Increase in pressure also will lead to increase in chemical reaction. That is for a reaction that leads to a decrease in volume. So it is only C that has increase in temperature, increase in concentration, and addition of catalyst, and increase in surface area of the reactant. So that is why is the right answer. So the formula for quicklime. So quicklime number 55 says quicklime has the formula A, calcium hydroxide, is A, calcium hydroxide, then B, calcium oxide, then C, we have calcium carbonate, then D, we have calcium sulfate salt with water of hydration, water of water crystallization, sorry. Then we have calcium chloride, calcium chloride. So that's E. So this is slaked lime. The odd name is slaked lime. So this is quicklime. This is the odd name. This is calcium hydroxide, which is the IUPAC name. Calcium oxide, which is also the IUPAC name, but it has an odd name, which is they call it quicklime. So that is the correct answer is calcium oxide B. This is the chemical formula for quicklime. So moving on to number 56. So a transition metal is different from a non-transition metal because A, it has an octet configuration. B, it is very stable. C, it is colored. D, it has incomplete outer shell, outer dish the outer shell D electrons. E, it has no electron in the D orbitals. The right answer is D. That is the major characteristics of transition metals. They have incomplete outer D electron shell. So moving on to the next question, number 57. What is the role of iron and aluminum oxide in ammonia? In ammonia, A, they are dehydrating agent, B, catalytic agent, C, oxidizing agent, B, D, bonding agent, E, preservative. So the answer is B, because in herbal process, which is the industrial production of ammonia, which is the industrial production of ammonia, iron and aluminum oxides are used as catalysts. So it is a catalytic, they are catalytic agents. So moving on to the next question, number 58 says, when carbon dioxide is bubbled into lime water, the solution becomes milky due to the formation of A, calcium hydrogen triiosocarbonate, B, calcium carbonate, C, calcium nitrate triisonitrate 5, D, calcium chloride, and E, calcium tetraoxosulfate 6. The right answer is calcium carbonate. Due to the formation of calcium carbonate, the answer is B. When lime water is CaO, when CO2 is added to lime water, so we have CO2 plus CaO, that it gives us CaCO3, calcium carbonate, and that is what gives lime water. That's what turns lime water milky. Presence of calcium and CO2. So moving on to the next, number 59. Which of the following gases dissolve vapor in water vapor to form acid rain during rainfall? A, oxygen, B, carbon 2 oxide, C, nitrogen, D, sulfur 4 oxide. The answer is D, because oxygen, though oxygen might dissolve in water vapor when in the atmosphere, it does not form any acidic substance. So though calcium 2 oxide dissolves in water to form an acid, it is a weak acid. It's not what causes acid rain, but it is due to sulfur 4 oxide SO2. When it mixes with water vapor in the atmosphere, it forms H2SO3, which is a concentrated acid, is a strong acid. So that is the acid rain is as a result of sulfur 4 oxide dissolving in water vapor in the atmosphere. Now, moving to the last question, number 60. It says, which of the following is not an allotrope of carbon? Diamond is A, diamond, B, graphite, C, Buckminster fullerene, D, all of the above, E, none of the above. So which of this is not? So the right answer is none of the above, because these are all allotropes of carbon. Although this Buckminster fullerene C60 might not be common, it is also an allotrope of carbon. So that's it with the questions. I hope with these solutions you'll be able to understand these questions you have treated. So I wish you best of luck in the pursuit, and I'm looking forward to seeing you in Afit. Thank you.